perceptron model to solve such problems. So that was a major point in the development of artificial neural networks. Then there was a slowdown due to the inability which was pointed out, or a major critique which was given by Minsky and Peppert as a modification required in the perceptron model. But eventually, with a gap of quite many years, again the learning of artificial neural networks was resumed based on the perceptron model, when this problem of linearly non-separable classification was solved with modifications to the single layer perceptron. So let's try to understand what this problem of linear separability is. For that, we'll consider the example of an OR gate as well as an XOR gate and try to see what is the difference between the two and what is linear separability. That you can consider simple OR gate. Okay. Now if we see, the OR gate functionality is that if any of the input is 1, my output is going to be 1. So either of the input is 1 or both the inputs are 1, output is 1. The condition is at least one of the input should be 1 for the output to be 1. So if I plot these as two inputs in my xy plane or in a 2D plane, so what do I get is, this is my axis for B, this is my axis for A. So if I see, these are the 4 points where I am going to get my 4 outputs. So at the origin, both A and B are 0. So here my input A is 0, that is, and B is 1. Then at this point both are 1 and this corresponds to 1, 0. So if I want to divide it now, I know that my cases or my values of A and B for OR gate, which are going to give me in the output 1 are this 0, 1, 1, 1 and 1, 0. So these are lying in one area and this point is lying in another area. Now if I want to use a line to separate the two regions of the output, where output is 1 in one region and output is 0 in the second region, I can clearly draw a line which is passing through the points A and B, or I can draw a line just at this point where these values are over, and I can divide it into two regions. So it means my regions of the output, I have binary output 0 and 1. So they can be classified, or these two classes of output, they can be separated by a linear or by a line. So they are said to be linearly separable. Okay. Now on the other hand, consider an OR gate. So this is the truth table for the OR gate, XOR gate. So XOR gate, what is the logic? If either of the input is 1, output is going to be 1. But when both my inputs are at the same logic level, 0 or 1, output is going to be 0. Now on the similar lines as we did for OR, if we plot these in a 2D plane, okay, so this axis I plot A, this axis I plot B. So I have these 4 points which are mentioning the values of 4 possible values of inputs A and B. Now I know that my output is going to be 1 for the cases 0, 1 and 1, 0, which are at the two corners of the square, whereas the output is going to be 0 for the 2 points which are the corners of, again, square diagonal on the opposite corners, you can see. Now if I want to divide these 4 points by a single line, can we do that? We can try drawing a diagonal line as we did. Are we able to divide? No. If I draw a line here, it will divide my space or the graph into two regions, where it is having output 0 here, with output 1 here, output 1 here. So it is not dividing it. Again in this region also I have the points where having output 0. So I'm not able to draw two classifications of the output. Let's say I draw a line in between. Again, both sides of the line, I'm having the points which are having output 1, output 0, output 0, output 1. So not possible. And draw a horizontal line. Again, both the sides, they will have the points with the output 1 and 0. So I can see I don't have any single line which is able to divide my this space covering the 4 points of my XOR gate into a two separable classes of the output, where one bipolar output is restricted in one region and other in other. So it is unable to classify using a single line into two separate output regions. So this is said to be linearly inseparable. So all the models we have done, perceptron model, MP model, adaptive linear model, Adeline model, these three as a single unit, they are not applicable to any non-linear problem. They can be only used for a linear separable problem. Okay, but if I try to build the layers of the networks, okay, as in case of Madeline, what did we do? We were cascading the Madeline together and mending it. Okay, so we were in that case we will be able to solve the non-linear problem using the this layered structure. Okay, so with that we come to the things not linearly non-separable are the problems in which no single line can divide the regions into two separate regions. We just take one example. Consider this plot. Consider this plot. Let it be A and this will be B. Now, if we talk about linear separability, which of the two you think is linearly separable? If we clearly examine, I can draw a line here in this region when my cursor is moving, and I can have division of this into two regions. In one side, I will have red points, other side I will have blue points. But if I want to classify here, I don't have any single line which can do that. So the question remains, how to solve this linear inseparability? The answer to this definitely lies in the models which have been developed over the time. Obviously, Madeline is one example I told you, but perceptron also can be used for that. MP model cannot be used for linearly separable problem, but perceptron model, which is the basis of most of the networks used nowadays, can be used for linearly inseparable or the non-linear problems. So we'll see that eventually. But with this, we understand what is the concept of linear separability and which neuron models can be applied to it. Now we come to next thing, that is the activation functions. As I told you, activation functions, they are going to determine what my output is going to be. So my scaling of the output, my range of the output, my values which are there in my output, they are determined by my activation function. Activation function can be any function like a hard limited function, or it can be a sigmoid function, or a Gaussian radial basis function, or a threshold function. Any function with one requirement, that it must be differentiable. Now why it is required to be differentiable? We will see this. First we will go through the commonly used activation functions. So the most popularly used activation function and the simplest of all, which was there since the beginning of the basic model of neuron, is the this thresholding function, which limits my output to be a binary output either as 0 or as 1. So it is simply going to work on the logic that if my V it is greater than equal to 0, output is going to be 1 else 0. So we normally make use of a threshold function using this for implementing this. It is also known as the Heaviside function. This is very clear. We have already seen it and its application in the NP model. Next function what we have is bipolar function. This is also known as the signum function or the sine function because it is going to give my output as a sine. Again, it can be expressed as if my output is greater than 0, summed output with the threshold or the bias, whatever has to be applied, that is already applied. If that is greater than 0, output is 1. If it is 0, output is 0. If it is less than 0, output is minus 1. So it allows my output to vary between -1 and 1, and it is a linear function. Next we come to is a piecewise linear function. Okay, piecewise linear matlab it is going to linearity is going to be uh, depicted in the terms of linear lines, each having a slope. So slope is 0 here, slope is 0 here, but in this range between minus zero point 0.5 and zero point 0.5, I have a linear range of this function. So it can be expressed using this. Okay, it is going to be 1 if the value is more than zero point 0.5. If it is values between minus zero point 0.5 and plus zero point 0.5, it is going to be linear with the value of the input, and else if it is less than the negative minus zero point 0.5, value is going to be 0. So it has a unity slope in the this region, and the output is again limited to -1 plus 1. Next we have a sigmoidal function which gives me a balance of linearity and non-linearity. So the slope can be non-linear, but again it is restricted to a range of values. So there is a slope. So normally we have two functions, that is logistic function and my tanh function, which are going to be used for this. Just would like to go to the last slide. This logistic function. So it should be just 1 over 1 plus 1 plus e raised to power minus x. So x is nothing but this value which is moving, or the slope you can say. So tanh, it is the hyperbolic function. This is also known as the bipolar sigmoidal function. So it is a nonlinear function and the value varies between 0 and 1. So it is S-shaped function, definitely an increasing function. The minimum value is 0 and it increases towards 1. Okay, so these are the popularly used functions. You can have other functions also, but these are the most commonly used, and this is what we'll be using also in our examples when we do the ANNs. So this is the brief summary of the functions which are used. Their how they look like, that is their pictorial representation, their representation in the form of mathematical equation, and their differential. Okay, as I told you, differentiation is very important. Why? Because when we are going to update the weights, okay, the delta function, which is the most popularly used from this learning rule, that is going to work on the differential or the slope of the output which is received. So for that to be achieved, I require my activation function to be differentiable. If it is not differentiable, we will not be able to apply our learning law, which uses the gradient or the slope of the output, because we are going to calculate the temporal processing. So whatever output I am going to get at the one instant of time, that has to be fed back so that my error is reduced. Okay, in the learning, that is guided learning. So for that I require my activation to be differentiable, so that slope of that particular activation function is calculated. So we require all the activation functions to be